Hi all, I'm Malavika, and in this video I'll be explaining about apoptosis or programmed cell death. Apoptosis is a pathway of cell death induced by a tightly regulated suicide program in which the cells destined to die will activate intrinsic enzymes that degrade the cell's own nuclear DNA and nuclear and cytoplasmic proteins. The dead cell and its fragments are rapidly phagocytosed before the contents leak out. This is why inflammatory response is not elicited in apoptosis. In contrast, inflammatory response is seen in another pathway of cell death called necrosis. Causes of apoptosis can be of two types, physiological and pathological. Physiological causes include embryogenesis, involution of hormone-dependent tissues on withdrawal of the hormone, cell loss in proliferating cell populations, elimination of potentially harmful self-reactive lymphocytes, and death of host cells after they have served their useful purpose. Pathological causes include DNA damage, accumulation of misfolded proteins, infections, and pathological atrophy after duct obstruction. Coming to the morphology of apoptosis, electron microscopy findings include cell shrinkage. The cell will become smaller in size and the cytoplasm will become denser. Chromatin condensation, cytoplasmic blebs and apoptotic bodies. A part of the cell will project out and this is called bleb, and this bleb will get pinched out from the cell to form apoptotic body. You can also see phagocytosis of the apoptotic bodies by macrophages. Light microscopy findings include densely eosinophilic apoptotic cells and nuclei which appear as fragments of dense nuclear chromatin. Apoptosis occurs in two phases. The initiation phase includes an intrinsic pathway or mitochondrial pathway and an extrinsic pathway or death receptor pathway. The second one is the execution phase. Before diving deeper into the mechanisms of apoptosis, we have to know a few concepts. The first one being the BCL2 family of proteins. The BCL2 family of proteins, they are of three types: anti-apoptotic proteins, pro-apoptotic proteins, and sensor proteins. Now, there are also enzymes involved in apoptosis called caspases. They are of two types: initiator caspases, which are caspase 8, 9, and 10, and executioner caspases, which are 3, 6, and 7. As you can see here, apoptosis consists of two phases, initiation phase and execution phase. The initiation phase includes the intrinsic pathway and the extrinsic pathway. In the intrinsic pathway, factors like DNA damage, growth factor withdrawal, protein misfolding, and hypoxia cause cell injury. And this will activate the sensor proteins of the BCL2 family, which we have already mentioned. And these sensors will activate pro-apoptotic proteins of the same BCL2 family of proteins, which are BAX and BAC. BAX and BAC will increase the mitochondrial outer membrane permeability, and cytochrome C, which was stored in the intermembrane space of mitochondria, will be released into the cytoplasm. Cytochrome C will then combine with apoptotic protease activating factor 1 to form apoptosome. This apoptosome will activate caspase 9, which, if you recall, is an initiator caspase. Caspase 9 will further activate executioner caspases. The extrinsic pathway involves ligand-receptor interactions. An example of one such ligand is the Fas ligand, which is present on T lymphocytes and natural killer cells. The corresponding receptor is Fas receptor or CD95. When Fas ligand binds to Fas receptor, the receptor will undergo trimerization, and this will activate an adapter protein called Fas-associated death domain. This will further activate caspase 8 and 10, which are again initiator caspases, and these caspases will activate executioner caspases 3, 6, and 7. In the execution phase, activated caspases 3, 6, and 7 will cause endonuclease activation, which will lead to nuclear fragmentation and also breakdown of the cytoskeleton. Another example for a ligand receptor interaction in the extrinsic pathway is TNF receptor 1 and its ligand TNF alpha. This image shows all the mechanisms of apoptosis in detail. So here you have the mitochondrial or intrinsic pathway, and here you have the death receptor or extrinsic pathway. This is the execution phase. In the end, a cytoplasmic bleb is formed which will pinch out to form an apoptotic body, and this apoptotic body will be ingested by phagocytes, usually macrophages. Removal of apoptotic cells and bodies is by phagocytosis. The factors favoring phagocytosis are phosphatidylserine, soluble factors like thrombospondin, which are produced by the apoptotic cells, natural antibodies, and complement proteins. Disorders related to dysregulated apoptosis. Disorders in which apoptosis is reduced include certain cancers and autoimmune diseases. Disorders in which apoptosis is increased include neurodegenerative disorders, for example, Alzheimer's disease, ischemic injury as seen in MI and stroke, and in viral infections, mainly in AIDS. So that's all about the topic of apoptosis. Thank you for watching.